We are from Group A2, and our title for end of chapter is Hardware Interfacing 1, LCD Digital Calculator. Before we start our presentation, allow me to introduce myself together with my teammates. My name is Anson Hui with the matrix number of 01DM22F1013, and my teammates are Dinesh Kumar, 01DM22F1001, Yu Jian An, 01DM22F1004, last but not least, Tam Boon Tiong, 01DM22F1016. Alright, this will be the agenda for our presentation. We have 4 parts: theory, flowchart, MPLAB programming, and Proteus professional design circuit. Let's start off our presentation with theory. There are 4 main parts for this. The first one, basic components of the digital calculator. So there are 4 points for this part, which are power source, keypad, microprocessor, and display. Let's go into the first one. Power source. It is usually a small battery or solar cells. Secondly, keypad. It is an input and it allows users enter numbers and operations through this interface. Thirdly, microprocessor or IC. It is the brain of the calculator. This chip performs all mathematical calculations, and it also receives input from the keypad, processes the data, and then sends output to the display. Lastly, display, also known as output. The result is displayed on an LCD screen. Second part, liquid crystal display, also known as LCD technology. Let's go into the first one, liquid crystals. LCD technology uses liquid crystals that can align themselves in response to an electric field. These crystals do not emit light themselves, but modulate light passing through them. Second one, polarization. LCDs rely on polarized light. 2 polarized filters are used, and the liquid crystals alignment between them controls how much light passes through. Thirdly, electrodes. The calculator's microprocessor applies voltages to specific electrodes corresponding to the segments of the LCD screen. The last point for this part, segments. Each digit on the LCD screen is represented by 7 segments that can turn on or off to form the numbers from 0 through 9. For more advanced calculators, additional segments are used for other symbols and operations. Followed by the third part for theory, functionality of a digital calculator. So I separate it into 2 different points. The first one, input and processing. The second one, display output. Let's look into input and processing. When a user presses a button on the keypad, this input is encoded into binary form and sent to the calculator's microprocessor. The microprocessor is then processed the input, performing a desired operation. For display and output, after the calculation, the result is converted back into a format suitable for display. The microprocessor controls the LCD segments by applying voltage to specific electrodes, causing the liquid crystals to change their alignment. These segments display the numbers and symbols representing the result. And finally, the last part for theory, types of calculations. There are 2 points. Basic calculators perform simple arithmetic such as addition, subtraction, multiplication, and division. For more advanced scientific calculators, can handle complex operations such as trigonometry, logarithms, exponentials, using similar principles but with more sophisticated microprocessors and larger displays. That's all from my part, and I'll pass it to Tan.
My name is Tam Boon Tiong. My matrix number are 01DM22F1016. I will follow up for the flowchart. So first of all, we start with the system indicating the calculation process. At this point, the program is fully ready to take input from the user. Next, the interface is displayed to the user. This allows the user interact with the system, typically by entering a value using a keyboard. After, the system wait for the input from the keyboard. It keeps checking until a value is entered. Once a value is detected, the process will move forward. And then once the keyboard is detected, the system retrieves this value for further use in the calculation. Now the system checks for the function to be applied, for example addition, subtraction, plus, minus. So it waits if no function is there. And once a function is provided, the process will be continued. And then the system retrieves the function capturing the operation that the user wants to perform. The system looks for a second input value similar to the first. It waits until this value is checked before moving on. Once the value is once the second value is entered, the system retrieves it, preparing for the final calculation. With the both value and the function in place, the system performs the calculation and output the result to the user. So that's all. Thank you very much.
Thank you for Tan Boon Teo, and now I will continue about the programming part. I'm DJM matrix number 011022F1004. Okay, in the first picture, we are defines the pin out of the keypad using the port C. And then looking for the second pictures is the main program for our microcontroller that first it will initialize the LCD first, and then it will display the first number, and then we will need to insert the first data by pressing the keypad. After it reads the first data, it will change and display the second one on the LCD that operator. Yeah. At this time, we need to press the function button from the keypad, and it will read it and save it for the next step. After we press the function button from the keypad, the LCD will display the third one that enter the second numbers. When we finish up, press the second numbers, it will display the LCD will display the last one, the result of the calculations. Okay. If about the keypad functions, we can look on the starting from the picture 5. This check scan key is the function for the keypad. When we press the row 1 and the column 1s, we can got the data 7. It seems like another ones. Picture 5 and picture 6 all is the program to learn it. And then the 7 and 8 is the program to return and memorize the data to be the calculations. Okay, thank you. That's for me. I will pass to the Dinesh.
Thank you, Eugenan. My name is Dinesh Kumar, son of Subramaniam, and my metric card number is 01DEM22F1001. So the next part that I'm going to present about is Protheus Professional Design Circuit, which likely involves demonstrating how a circuit is designed using the Protheus software and showing a generated outcome or simulation of the circuit. Protheus is a widely used software tool for simulating electronic circuits, including microcontroller-based designs. In this, it was used to simulate a digital calculator circuit that interfaces with a LCD display. The goal of the circuit is to simulate a working digital calculator that can perform basic arithmetic functions. We use the Protheus software to create the circuit because it allows us to test and troubleshoot the design before building it physically. Each component, such as the LCD and microprocessor, was wired according to the circuit diagram. As you can see in the slide about the connection and wiring, so keypad is connected to the microprocessor. Each button of the keypad is connected to the microprocessor via general purpose input or output pins. When a button is pressed, it sends a signal to the microprocessor, which interprets the key press as a number or operation. So the second connection, as you can see in the slide, is microprocessor to the LCD screen. The microprocessor communicates with the LCD using several data lines. It sends control signals and data signals to instruct the LCD what to display. The data signals contain information such as which number or symbol to show, while the control signals manage tasks like clearing the screen or moving the cursor. So the third is power supply. The circuit is powered by a standard DC supply. So coming to the working of the circuit is about the input stage. When a key is pressed on the keypad, the microprocessor detects the key press and stores the corresponding number of the operator. And the second is processing stage. Once the user inputs the entire calculation, the microprocessor processes the operation using its arithmetic logic. The microprocessor performs the computation based on the operator and the numbers provided. When coming to the output stage, the result of the calculation is then sent to the LCD screen. The microprocessor sends the necessary data and control signals to display the final result. In summary, the circuit essentially forms a functional digital calculator where the microprocessor handles the computation, the keypad provides user input, and the LCD shows the output. The Prothi software allows us to simulate the circuit, verifying its functionality before physical implementation. That's all from us. Thank you so much.